God eftermiddag, så er klokken ved at være 14. Og normalt så ville I lige få et billede på skærmen af mig, men mit kamera, det har besluttet sig for i dag lige at strække lidt, og det er rigtig træls at kigge på det, så I får mig lige sådan her, bare kun med lyd. Mit navn er Bettina Lundgaard. Jeg koordinerer masteruddannelsen i IT på de 3 vestdanske universiteter. And maybe in this meeting, some of you will mainly speak English because all the courses we have this year is in, this specialization in software construction is in English. But what I'll do is I'll do the introduction in Danish. And then afterward, Hans, Jörg, and Manfred and Ashutosh will do their presentations in English. Så jeg slår lige over i dag på dansk igen og siger velkommen til. Jeg vil rigtig gerne opfordre jer til at bruge chatten, hvis I har spørgsmål. Vores oplægsholder vil gerne svare på spørgsmål, så gør endelig det. Og så vil jeg også sige til jer, at vi optager præsentationen her, fordi det er ikke alle, der har haft mulighed for at deltage i dag. På den slide, I har foran jer her, der kan I se vores 3 oplægsholdere. Hans Jörg, der skal have et oplæg om den fagpakke, vi kalder Visual Analytics, og Manfred, der lige skal fortælle om 2 fagpakker, Data Science og Big Data og udvikling af AI, som er en ny fagpakke, og så Ashutosh fra Aalborg Universitet, som skal fortælle om fagpakken Modern Security with Cutting Edge Technologies. Men velkommen alle sammen. Inden jeg lige går videre, så har jeg erfaring med, at ofte så er der nogen på deltagerlisten, som har læst på uddannelsen før, og I må godt lige meget gerne lige sige, jeg har læst før, eller jeg har læst den her fagpakke før, og I må også gerne bidrage, hvis I har nogle erfaringer fra uddannelsen, I gerne vil dele med nogle af de andre. Og til jer, der har læst før, så vil jeg også sige, at noget af det, jeg fortæller nu, det ved I godt i forvejen, så kan man svare på en mail eller 2. Det er I hvert fald velkommen til. Master IT er en uddannelse helt tilbage fra 2006. Og på uddannelsen, der kan man specialisere sig inden for organisation eller inden for softwarekonstruktion. Og det er på det, vi kalder linjen specialisering i softwarekonstruktion, vi fokuserer på her i dag. Der kan man også på sit eksamensbevis få et ekstra stempel inden for IT-sikkerhed og data analytics, og det skal jeg nok komme tilbage til. På den her uddannelse, der kan man både læse fag som enkelt, altså bare vælge at læse en fagpakke eller læse et enkelt fag, kun 5 ECTS, men man kan også vælge at tage en hel mastergrad. Og skal man det, så skal man læse 3 hele fagpakker, altså afslutte 3 hele fagpakker, og så skal man skrive et masterprojekt. De studerende, vi har på Master IT, de kommer oftest, fordi de gerne vil have ny inspiration. Måske til deres job eller et nyt job. Og så ønsker de den her akademisk dybde, og når vi sådan siger akademisk dybde, så er det mange af vores studerende siger til os, det I ser lidt over i tegningen her, at jeg vil gerne have et sprog, hvor jeg kan tale med topledelsen og udfordre min topledelse, som de kan forstå. Når jeg for eksempel skal argumentere for, hvorfor vi skal bruge lidt ekstra tid på for eksempel at lave sikker kode. Det, der er kendetegnet for masteruddannelsen i IT, for det første, så er det sådan modsat mange andre masteruddannelser, en uddannelse på universiteterne, hvor man selv kan vælge indholdet af den. Det vil sige, at man kan vælge de fagpakker, der enten er på linjen i softwarekonstruktion, eller de fagpakker, der er på linjen i organisation. Traditionelt på andre masteruddannelser er det sådan, at der er det universitetet, der vælger halvdelen af fagene, man skal læse, og så kan man selv kun vælge for 15 ECTS valgfag. Men her, der er det lidt ligesom en buffet. Og man kan også lade være med at tage mastergraden. Det kan være, at man har en kandidat i forvejen, og man tænker, jeg behøver ikke den grad. Jeg vil egentlig hellere bare læse det her fag eller det her fag. I skal være meget velkommen her. Det er derfor, vi har opbygget uddannelsen, som vi har. Det I også vil opleve, det er, at I læser på forskellige universiteter. Det kan I hvert fald vælge at gøre. Og det betyder også, at I møder forskellige videnskabelige miljøer. Hvis vi nu tager de fagpakker, I møder her i dag, så er Hans Jörg, han kommer fra et datalogisk institut. Det gør Manfred også. Men en af Manfreds fagpakker har et enkelt fag, der er fra et ingeniørinstitut nede i Odense. Manfred kommer fra Aalborg. Ashutosh, han kommer også fra Aalborg, men han kommer også fra et ingeniørinstitut. Og det er lidt forskellige miljøer på de forskellige institutter, så det er det, I kommer til at møde. I kommer også til at møde nogle forskere, der gerne vil præsentere jer for deres egen forskning. Så kan I også på nogle fagpakker møde eksterne oplægsholdere, men faktisk vil jeg også sige noget, der er rigtig vigtigt. I møder også hinanden, Og det vi oplever ved mange af de studerende på vores uddannelse, det er, at man også får et netværk, hvis man selv byder ind med det. Så I kommer også til at møde en masse dygtige studerende, som I kan videndele med. Her er lige lidt fakta omkring vores uddannelse, hvor I kan se, hvor mange der har læst på den siden 2006. 553 har taget graden ind til og med her i januar i år. Og så kan I se, at vi faktisk har en del studerende, som vælger at tage turen fra Sjælland til Aalborg eller til Aarhus og studere hos os. Og som jeg nævnte i starten, så behøves man ikke at tage en hel fagpakke, som er det, I får præsenteret her i dag. Nogle af vores fagpakker er opdelt i mindre bidder, og derfor kan man godt tage et enkelt fag, hvis man tænker at tage en hel fagpakke. Det er godt nok lige for stort til mig. Jeg vil egentlig gerne bare nøjes med et enkelt fag, så er det muligt at gøre det. Det her er bare et lille billede af de virksomheder, som de studerende har repræsenteret gennem tiden på vores uddannelser. Som kan I se, så kommer de også fra mange forskellige brancher. Så det er ikke kun IT-branchen, der læser på den her uddannelse. Rigtig mange virksomheder i dag har jo også softwareudviklere ansat, så derfor er mange forskellige virksomheder repræsenteret her. Noget af det, I også kan møde, det er, at I kan møde undervisere, som bruger den her uddannelse til at opgradere sig selv, enten fordi de underviser for eksempel på en ingeniøruddannelse, eller på en anden teknisk uddannelse på nogle af professionshøjskoler, men sandelig også på universiteter. Jeg nævnte lige, at vi har 2 specialiseringer, når man læser på linjen i softwarekonstruktion. Og på det jeg mener, det er en slags underspecialisering, det vil sige, at man får et lille stempel på side 2 på sit eksamensbevis, men der står, at jeg har specialiseret mig, fordi jeg kun har læst fag inden for det, vi kalder IT-sikkerhed, som er eksemplet her. Der skal man tage 2 fagpakker af dem, der står i kassen til højre, og den tredje fagpakke kan man enten tage fra kassen til højre, eller fra det, vi kalder informationssikkerhedsfagpakker over på linjen i organisation. Der er lige nogle regler for, at for eksempel kan man ikke både tage netværkssikkerhed og så den, der hedder teknisk IT-sikkerhed for generalister, fordi de er 2 udgaver af næsten samme sag. Men ellers. Specialist i Data Analytics. Der ser I også blandt andet Visual Analytics og Data Science og Big Data og udvikling af AI på menuen her i dag. Og igen her 3 hele fagpakker inden for feltet til højre, og så en valgfri fagpakke enten fra listen til højre, eller er de valgfrie over fra de 2, vi har på linjen i organisation. Så vil jeg fortælle jer, at vi også laver nogle gratis aktiviteter. Vi holder en konference i efteråret, og den her konference, det kommer til at handle om nok det store samtaleemne lige nu. Det oplevede jeg i hvert fald på en konference her i marts, som jeg var til ved Tech Hub Aarhus. Hvad er det, vi som for eksempel softwareudviklere, vi gerne selv vil lave, og hvad vil vi gerne have maskinen til at lave? Synes vi, det er sjovt at sidde og administrere 10 AI-agenter? Ser vi det som en karrierevej? Og få den samtale, blandt andet blandt ledere, er noget af det, vi håber, vi kan få på den her konference. Hvad er det, vi som mennesker gerne vil lave, og hvad er det, maskinen skal lave? Jeg har inviteret et par humanistiske forskere til at give nogle oplæg på det, og også nogle oplæg på, hvordan vi arbejder med forandringsledelse med den her teknologi, der tordner ind over os. Til sidst vil jeg sige til jer, at I kan følge Master i IT. Hvis det er sådan, at I ønsker at følge os på sociale medier, så er vi på Facebook og LinkedIn, der kan I følge os. I kan også vælge at tilmelde jer vores nyhedsbrev, og der vil I også få opdateringer. Og når jeg lige nævner det her, så er det fordi, når vi kommer med nyheder, for eksempel når vi kommer med nye fagpakker, så er det her, vi skriver det. Så det er et godt sted at følge med. Det er også her, vi siger, nu lukker vi en fagpakke, nu kommer vi ikke til at køre den længere. Så er det et godt sted at følge med i det nye udbud. Det var det, jeg ville fortælle jer her indledningsvis. I er meget velkommen til at stille spørgsmål ude i chatten, som jeg nævnte. Og vores første oplægsholder, det er dig, Hans Jørg. Vil du dele din skærm?
Yes.
Og mens while Hans Jørg is doing this, I'll present him. Hans Jørg, you are at the Computer Science Institute at Aarhus University, and you're talking about the course within Visual Analytics, and the floor is yours.
Yes, I'm on more second. I'm missing
This
one
looks
thing.
really good.
Yes, I know, but
Oh,
come on. I need this because I need to share my sound. So that's the trick. And then let me get this started again. All right, so here we are.
perfect. Perfect.
Thank you very much, Bettina, for your kind introduction. That works, right? Yeah, perfect. Good. So visual analytics. The first big question is, of course, what is visual analytics? And a definition that I particularly like is this one here that says visual analytics combines the strength of both worlds. On the one hand, taking advantage of intelligent algorithms and vast computational power of modern computers, and on the other hand, integrating human background knowledge and intuition to find a good solution. So what does that mean in practice? In practice, this is the situation we are faced with. When we do a data analysis, there are certain tasks that the computer is really good at. Data storage, numerical calculations, data retrieval, right? Searching and finding. These are all things that I, as a human, are really bad at, but the computer excels in. But there are other things that the computer is pretty bad at. Common knowledge, background knowledge, yeah, cognition, creativity. So these are all things that are extremely hard to teach to a computer. But we humans, we kind of have expertise. We know how to interpret data and what it means and whether something is a plausible result or not. The main idea behind visual analytics is that we say that a data analysis consists of both kind of tasks and they are interleaved. So a data analysis consists of tasks the computer is really good at, but also of tasks that the human is good at. So we want to combine the best of both worlds as the definition said before, yeah, kind of like this. And you can say that this is already the makeup of this particular course package, because I am not teaching this course package just by myself, but I'm teaching this course package together with the associate professor, Davide Motin. And Davide is an expert on that back-end part, on the data mining, on the machine learning part of things, the data analytics, whereas I'm the expert on the front end things, so the visualization, the interaction. And we have teamed up to offer this particular course package. So in the first course, Davide will teach about the data mining and machine learning, running in the background, crunching the data. Then in the second course, I will talk about data visualization, how to present the results of this data analysis to the human user so that they can make sense of it, adjust parameters, hyperparameters, rerun analysis until it makes sense if it doesn't in the first go around. And then there is the third course, which is the visual analytics project that combines these two worlds with each other in one project that you would then build. So in detail, what does that mean? The structure of this course package is as follows. The first course consists of 3 course days, and they are all run by Davide, and he will be introducing into Python for data analytics in the first part. So think pandas and data frames and scikit-learn and so forth, so that you have the means to run these analyses. And then he spends another course day on unsupervised learning methods. So that would, for example, be clustering methods, outlier detection methods, dimensionality reduction methods. So all methods that, without having explicitly labeled training data, give you an idea of how your data space is structured. Yeah, so think you might be an administrator in charge of a couple hundred servers at your company. How do you find the outliers that behave different from all the others in some shape or another? So unsupervised learning can help you with that. And then the third course day is the supervised learning, and that is where we actually have training data and do a classification based on this. So we have ground truth on which we can learn a model and then use this model to predict for data that the training has not or was not seen during the training, right? New data coming in. That's the first course on data analytics, the back end, so to speak. On top of that comes then the second course, data visualization, where we will spend the first course day looking at chart types. That means chart types that you think you might know, like line charts, bar charts, scatter plots, but we will look really in detail on how to construct them so that they make sense perceptually for our eyes, are easy to take in, are doing their jobs. And then in the second course day, we look more at the interaction of things. Yeah, so how to create interactive visualization pipelines so that the chart changes based on the interactions we make. And finally, there will be a part on visualization design, because at some point you will be tasked to build a visualization, but what is actually a good visualization and how do you arrive at that? And finally, there comes the course number 3 with this visual analytics project, which is jointly supervised by Davide and me. And here we will have, on the 3 course days, we will have short presentations on relevant topics: human in the loop paradigm, mixed initiative visual analytics, progressive visual analytics, to give you an overview of the different flavors in which this combination of human and computational analysis can happen. And there will be, of course, project presentations and time for, some supervision meetings. And the assessment for these courses looks as follows. Course 1 and 2, the assessment will be done based on 2 homework assignments and 2 in-class tests. And then course 3, there will be a hand-in and an oral exam. Just to give you a bit of an idea of what that means, I have taken a snippet of an old visual analytics project that was done by a student. There is a video that should play in a moment, and that gives you a bit of an idea of what visual analytics really means and what you can do with it. What you will see is there is this Bayesian network that's been trained on some data, and then you can interact with this model to really drill into the, different relations between the aspects of the data. So that's all been explained in the video.
Then we can here click in the bar charts on, for example, we want to know, okay, so what are the characteristics of people that actually get approved their credit status in our sample. So then we click here and approve that. Then have 100% because we have set evidence that a credit status node now is approved. And then we kind of look in the rest of the graph of a visualization. Now all things you see are now for the people in the sample that have been approved. So then we can just look maybe around here, zoom in again, and then we can see, okay, most people that got approved have actually just had less than one person that was dependent on them. Also, it seems like the amount of loan doesn't matter that much for getting approved or not, as it's pretty evenly distributed, but it seems like it is better to maybe loan for a longer time than for less time. And it's good, or in the sample, most people that got approved had a worker position and had big salary. So yeah, that's a bit how it works. Then of course, if we zoom out, we can just zoom in and pan around and look. And here, when a node is active, so if we have set evidence, then it will have this red frame around it, so you notice where you have already set evidence. Okay, so this is the one kind of approach to it. Then if we want to take evidence out of the network again, then we just click again on the label, and it will now go to the start again because we have no red boxes. So like this is just like the start page again. So now we can, for example, try to be like, okay, so if I now zoom in and say I'm a student, so what will then happen to my credit status? And I can see that in the sample or in the data set, the students, they are less likely to get their credit approved than the average. As you can see here, on average they are 5.82% of the people who got approved, and of the students they're only 3.6. Okay, we can also take off more than one node at the same time. So for example, as a student, I normally don't have any dependent family members. So then this is increasing my probability a bit of getting the loan approved.
All right, so you get the idea here, hopefully. Now, this is of course a toy data set, right? But imagine as you would do it in your visual analytics project, that you use some data set from your own company. Yeah, let's use the administrator example again. You have all your servers with all the different properties, the load they are under, the patch level they have, etc. And then you train this network to kind of model when servers, I guess, break down and when they are live. And you get this prediction you can drill into. You can say, okay, which properties really govern the failure rate of my server, etc. Yeah, so this is a very nice example of a back and forth between a computational backend and a visual front end that helps you to reason about the system that is captured by the data and to drill into it. A few
Then we can
yeah. Bettina already mentioned it, the course package will be taught entirely in English, so that also includes all the quizzes, homework exercises, and the oral exam at the end of course 3. So it's important that you are proficient in English to really ace all these, I guess, assessments. The course package is not a coding bootcamp, so it's really about the underlying principles of data visualization and data mining. And there is a reason for that, right? One is that we don't want to teach you knowledge that gets outdated in 2 years from now when the next best library comes out and you have to relearn anything from scratch. Another reason is that these days you have Claude Code and other generative AI tools at your fingertips. So it really doesn't, it's not a good use of our time together to teach you something that you could easily, with a simple prompt, get from those sources. And finally, if we taught you how to code these things, what would be completely left out is what to actually code. So which design decisions to make, how to make this trade-off of making a truthful representation of the data, a useful representation that can be used by the user, an aesthetic representation, a representation that is accessible by people who are vision impaired, for example. So there is a trade-off to be made, and that is not something that you learn from teaching you coding, lines of code, but that's really something where we have to dig into the models and theories underneath. A little different, course 3 will, of course, when you do this project, it needs to be completed in some kind of programming language, but that is a programming language of your choice. Anything goes, even if you want to do an Excel plugin, yeah, Visual Basic for applications or Power BI thing or whatever, it's all possible. We are really looking at the design choices you make. And finally, since I'm getting asked this a lot, what is the reading list for this course? We rely mainly on these 4 books. The first 3 books are freely available on the web. The 4th book, I will make the necessary chapters that we are going to read available then via the learning management system. So you can already dive in today if you want to and take a look at those. And yeah, maybe you want to take a screenshot of this if you are interested to follow up on these links. And that's it from my side. And if you have any question, now would be a good time to shoot.
Thank you, Hans-Jörg. There's no question in the chat, so I think we'll leave it there. But if any of you have any questions later on, you can write to Hans-Jörg, and you can find his contact data on our website. So thank you, Hans-Jörg, for today, and I hope you have a nice afternoon. And if you unshare, then our next presentation is Manfred. No, sorry. Yes, it is Manfred. Yeah.
Yes, it should
Yes,
be.
it should be
me.
you.
Okay.
Yeah.
Let me try to share this.
And while Manfred is sharing, Manfred is working on computer science at Aalborg University, and you're talking about 2 courses right now. So the floor is yours, Manfred.
Okay, yes, so I'm going to present both the data science and big data fagpakker and the development of AI, and I'll say a little bit about the relationship between these two also. But first, let's start with the data science and big data. So first, data science is not only about big data, so I have here to emphasize that, also some examples of smaller data sets, let's say a financial spreadsheet, or maybe that tends to be big, a medical patient database. Maybe we have sensor network data. Maybe we have a little bit more unusual data like images or raw text. So we are concerned with all kinds of data and what we can do with that in terms of predictive and descriptive analysis. That's also related to what Hans-Jörg has just described for the first course of his fagpakker, basically data analytics. But let's summarize a little bit what we mean by data science. That includes data management, which is how to pre-process data, transform data such that it becomes manageable and suitable for analysis. Then we have descriptive analysis. So that's what Hans-Jörg called the unsupervised data analysis, where we find patterns in the data, where we maybe visualize data, but data visualization per se is not part of this fagpakker. That's Hans-Jörg's business. What we are mostly concerned with here is what we call predictive modeling, and that is making predictions for the future based on observations of data in the past. For example, you have financial data and you want to predict the market, how it develops in the future. You have medical data and you want to use it for diagnostics. You have sensor data and maybe you want to use that for predictive maintenance, trying to find out which of your modules in the equipment is likely to fail next and may benefit from some maintenance right now before it actually causes some damage. Image data, well, that's of course currently a very big thing. You have traffic scenes and you want to use that to train a model for autonomous driving. Or maybe when you go to text data, you have a collection of text and you want to build out of that a predictive model that tries to categorize new text that you find. All of this is a blend of statistics and computer science. So statistics plays a big role of course, in data analysis, and computer science in making it actually work on a modern day computer. For who is this fagpakker intended, or who can benefit from it? And just looking at who was taking this fagpakker in the past, well, participants came from all kinds of backgrounds. They came sometimes from financial institutions, banks or insurances, from consultancies, also from industry. By industry here, I mean a productive production industry, manufacturing. Maybe from the energy sector, public administration, and also education sector. So people who just wanted to upgrade their competencies from an academic point of view. The content of this fagpakker is basically summarized as showing you methods and principles. That means introducing you to the basic mathematical tools, showing the key ideas and principles of data analysis and the concrete algorithms that we use for that. Then there is the use of software tools. And here we are especially looking at the R package for statistical analysis, Python for machine learning, and Apache Spark for big data management. Then we have example applications. So we present you with some applications in the exercises and little mini projects that we do as part of the courses. The fagpakke is structured to contain 3 courses or enkelpay. First is Introduction to Data Science. Second is Data Models and Analysis Techniques. And then number 3 is the Scalability to Big Data. Each of these courses is organized in a similar way. We have 3 full-day seminars with a mixture of lectures and smaller exercises that one can get direct hands-on experience with the things that we present. Between the seminars, you can spend the time reading, and we give you larger exercises or mini projects that you can work on in the 2 to 3 weeks between two seminar dates. And this can be done in small groups of 2 to 3 people if you can or want to organize yourself such that you can collaborate in small groups. And then we have an oral exam about 2 to 3 weeks after the last seminar. And as Bettina already said, it's also possible to just sign up for one of these 3 courses. So I'm now very quickly reviewing the content of these 3 courses and the formalities. The first, Introduction to Data Science, that's taught by the Math Department. We have the seminar days and into some topics that are mentioned here. It's basic statistics for data science, with basically touching on many key aspects already: visualization, data summarization, outlier detection. And this course will be based on R as the underlying software package. The second course, Data Models and Analysis Techniques, is taught by the Computer Science Department here at Aalborg University. And that's about basic data mining and machine learning techniques. Also focusing on predictive methods that I have kind of highlighted at the beginning, a little bit on descriptive analysis, and we put some focus on principles for evaluating machine learning models. So not only how to get them, but also how to find out whether they are any good. And for this course, we are using Python as the underlying software tool. And the third course is about big data, now really big data, where the focus is on scalability, really scaling the techniques that we have introduced in the first 2 courses to big data sets, using the data management platforms for managing big data. This is also taught here at the Computer Science Department at Aalborg University. A final word on what is stated as the prerequisites for this course or for this fagpakke. So it emphasizes the need for a little bit of mathematical background, that we know a little bit about vectors, matrices, differential calculus, about at the A level niveau at STX. And of course, there should also be a little bit of knowledge in computing, algorithms and data structures, and computing programming languages. Now we are relatively flexible. We with giving dispensations for these admission requirements, because we see that many people come with a different, let's say, career path, but have during their professional life accumulated enough expertise and experience with computing and with data that we don't really usually insist on any formal requirements, as long as you can say or describe that from your practical background, you have the necessary requirements for following this course. Okay, that's what I had for this fagpakke on data science and big data. If there are any questions, I first stop sharing these slides here.
Oh, there are not any questions at the moment, so I think you can just continue, Manfred.
Yes, then I just share my slides for the Ulrikling. That should be this one.
That looks good. Yeah.
Okay. Now I've done something. Let me just. I have to move this first to another screen. Okay. So this is a new fagpakker. We haven't run it before. And since it's new, I also prepared completely new slides. And now since time has moved on, since I prepared the slides for the data science fagpakker, I now went modern and asked ChatGPT for a nice motivating introductory slide. Using the prompt, draw a cartoon-style picture that symbolizes the usefulness of AI software tools for business. Then it came up with this nice picture showing all kinds of fancy things that we can do with artificial intelligence. And that in one box it says data analysis, content creation, emails and chats, reports and summaries, workflow automation. Now this is a little bit too broad, because if you read the description of the fagpakker, then it contains a statement that says, this fagpakker is not about generative AI. And half of the things that are listed in this little cartoon are about generative AI. So I changed my prompt and said the picture should contain more content relating to the use of predictive machine learning models and less about the use of generative AI. Then ChatGPT came up with this picture here. And that's pretty good. It sort of emphasizes the machine learning methods and tools and applications for predictive modeling. And especially if we look at the top box that is here displayed in this picture, predictive machine learning models. And if I cut this out and put it into my own graphics, then this actually describes pretty well the second course I have described in the data science and big data fagpakker, the data modeler and analysis technique course in this fagpakker. So that's a pretty good match with this part of the figure that ChatGPT gave me. And then just for a reminder, I have here on the left and the right, Introduction to Data Science and Scalability to Big Data. These are the other two courses in the data science fagpakker. So data models and analysis techniques are central to the whole endeavor of using machine learning and AI tools. And therefore, this also is a course or a module in this development of AI fagpakker. So the fagpakker that I'm now describing, development of AI, also has as one course this course on data models and analysis techniques. But it is using this course as the first introduction course and then builds on that to dive more deeply into the software engineering aspects of AI tools. So then we have two other courses or modules in this fagpakker. The second one is called Software Engineering of AI Systems. And the third one is a project on developing AI systems as a research or development project. So these two fagpakker have some things in common, but they are also distinct. And let's say short summary of how they are distinct is that the first one, data science and big data, is focusing more on the needs of a data analyst. So someone who has to manage big amounts of data or relevant amounts of data, but uses mostly existing software tools to provide a valuable data analysis. Whereas the development of AI fagpakker is more directed at software developers who really want to develop new software tools to support customized data analysis for the company or the business they are working for or they're working in. So that's the main, let's say, distinguishing feature of these two fagpakker. And I should say, since they share one course, it is not possible to take both of these fagpakker and get them as credits for the full master degree. So as Bettina mentioned in her introduction, a full master in IT is composed of 3 fagpakker plus the final project, and we cannot take both these data science and the development of AI fagpakker as parts of this full master program. So let's look a little bit more into the content of the development of AI fagpakker. So we have these 3 courses or 3 modules: data models and analysis techniques, software engineering of AI systems, and then the project. The first 2 modules or courses are organized again in the form of 3 full-day seminars that are a mixture of lectures and small exercises. And between the seminars, we have reading assignments or reading material and exercises or mini projects. The 3rd module is a project that is done on an individual basis. That means it's customized to individual participants. It is possible to only sign up for module 1 or 2. It doesn't make sense to only sign up for module 3 because that is based on module 1 and 2. So the first module is, again, it's the same, and I don't need to repeat it. It's the same module as we have in the data science fagpakker, the machine learning module of that fagpakker. The 2nd module is software engineering of AI systems. And this is taught at SDU. We have the seminar days here. So that's in January and February. And this is about really the software engineering, software development practice of AI systems and how they differ from, let's say, software engineering practice for other software tools. So scalability, quality assurance, and deployment are the central questions here. This is not exactly my area of expertise, so I cannot tell you a whole lot more details than what is here written on the slides, what is part of the of this engineering course in this fagpakker. Then the 3rd one is a project. Again, this is mostly supervised and taught by SDU, even though there could be also maybe some arrangements where it could be maybe supervised at Aalborg University, but for now we think of this as being mostly the supervision located at SDU. But dates and supervision can here be handled flexibly on a case-by-case basis. So this is a project where the students should work with either individually or in groups with one self-chosen problem statement within the theme of this fagpakker. The prerequisites are similar to what we had in the data science fagpakker. I think it's a little bit less, the mathematical background probably a little bit less critical, but a little bit more experience with programming and software development certainly is expected for this fagpakker here. There is a hope that people will also have some knowledge already about cloud computing and cloud platforms. But again, it's not a requirement, and usually we are always pretty flexible in evaluating individual career paths, individual statements of interest, and individual prerequisites, and to judge whether they give a good foundation for actually benefiting from the fagpakker that we offer. So this was my little presentation of this new development of AI.
Manfred, Andreas is asking whether the 2nd and the 3rd course taught by SDU means Syddansk University. Is the teaching in Odense, he's asking?
Yes, so the seminars here are planned to be held in Odense.
So the first seminars at this course is taught in Aalborg at Aalborg University, and the 2nd and 3rd part of this course is taught in Odense by Syddansk University.
Yes. Well, for the 3rd, I think it can also be, let's say, online, so I don't think it will be needed to travel to Odense for that.
No, only for the second part.
Only for the second part.
And Andreas, when you get your diploma, you will get the diploma from Aalborg University. So it's a professor from or employee from Syddansk University, the engineering, that is teaching at the second part. And he's also asking, is it a requirement to be fluent in Python? Would it be able to follow with my Java knowledge?
Yes, you would probably, I'm pretty sure. So we are not really doing a Python programming, only that the software tools that we use are in Python. But anyone who has basic familiarity with programming languages can basically on the fly manage the little pieces of Python code that we need in this fagpakker.
Yeah, cool. And he's asking, is A-level mathematics required for me to apply to this course? I have B-level mathematics, but I'm currently studying vector matrix and differential calculus to prepare.
Yeah, so that's then exactly what you need to put into. I think you have to submit a little bit and request for dispensation, and then you just write that you have privately studied these subjects, and then we can always say yes to that.
Yeah. Another one is asking the description of the third part of the last course here. Normally, the third part of the course is a project. So Runge is asking, so Runge, when you see our courses are divided in 3, normally the last part is a project where you work with the things that you've taught in 1 and 2, and then in the third part, what you do there is you have your own project, typically a project that you do for your company, where you show us that you have you can use what you've learned in the first 2 courses. So I hope that's is answering that question. Yeah, that's it for the questions. I think, Manfred, thank you very much.
Okay, thank you.
And Ashutosh, you're really welcome to share your screen. There you are. And Ashutosh is,
Yes.
and you're trying, yeah, perfect. Ashutosh is employed at Aalborg University at the engineering department, and you're currently in Copenhagen. Ashutosh, we can't see your presentation at the moment. We can only see you.
Okay, not yet, just a minute.
Yep, perfect. So now we can see it. It's fine. Thank you.
Yeah,
The floor is
so,
yours.
okay. Yeah, so my name is Ashutosh, and I'm an assistant professor here in Copenhagen campus, Aalborg University. And my research area is mainly focused on the cryptography. That means from past few years, I have been doing some cryptanalysis. That means trying to find the weaknesses and turning these weaknesses in the form of attack. So I have been working with the cryptography and post-quantum cryptography. And this is a course that I developed from the scratch. So this is the picture that I always try to show in my all cryptography classes, just to visualize what we are doing. So you can see here, Alice and Bob, they are trying to communicate over an unsecure channel. And whatever we transfer the data to the internet, we call it unsecure because it's just public media, right? And there is a guy called Oscar who is trying to hack the network or trying to steal the messages from the network. And therefore, we need some kind of encryption, and also to make sure that we are talking, I mean, Alice is talking with the Bob, not actually with the Oscar. We also need a kind of authentication. And from encryption to authentication, we actually use a kind of a key. And key is generally hidden with the attackers. Only Alice and Bob, they know the keys. We cannot give it to anyone else apart from Alice and Bob. So throughout the course, around 40 to 50% of the course, we are trying to secure these keys from the attacker. And key is everywhere. I mean, if the attacker have the access of this key, they will have access of your MIT-ID. They will have access of Wi-Fi, VPN. They can access the cloud computing. So I don't remember, at least for now, that in the networking, I don't know where we don't use key. When we talk about the network security, we always use a kind of key to secure the encryption and to secure the authentication. So the first course is all about the applied cryptography. And in the applied cryptography, we will go through some kind of encryption. We talk about the symmetric and asymmetric encryption. And when we say symmetric and asymmetric encryption, that means sometimes we try to use the same key. Alice and Bob, they use the same key. And when we talk about the asymmetric encryption, we use different keys. And that is possible with the help of some mathematics. And therefore, you can expect a little bit of mathematics in my first course of applied cryptography. Of course, it's not very tough mathematics. We start from the scratch, but you should expect that you have a bit of knowledge, or at least you are willing to get some knowledge of mathematics in this course. We also talk about the AES encryption. Nowadays, we are using a lot these AES encryption. We have also used a DES encryption in past few years, but that is now broken. So nowadays, we are not much using this one. And then we also talk about the authentication algorithms. Authentication algorithms is like when you do a banking or something, you have to prove that this is you, not somebody else. I mean, this is not the Oscar, but this is either Alice or Bob. So authentication is also one of the most important factors of today's security. And then nowadays, because we have these quantum computers and they are developing very rapidly and growing very fast. And what are these quantum computers? They are actually very fast. They use some kind of a physics, and they can calculate, they can do some kind of a calculation very fast. This is just like you have this number keys on the right-hand side. And if I give you to find the actual combination to open this lock, maybe you will spend the whole day to find the combination. But if I give it to the quantum computers, they will break it maybe in few minutes, or even larger keys, they can break it in few minutes. So this is actually the threat nowadays in terms of, I mean, if you just think like an attacker, you can use these quantum computers to break these keys, in few seconds. So nowadays, what we are doing is we are transferring all the, we are moving towards from classical cryptography to the post-quantum cryptography. That means we are updating all the devices with post-quantum cryptographic algorithms. And either we talk about the IoT devices, or we talk about the computers, or we talk about the network communications. Everything should be updated with these algorithms so that quantum computers cannot break these keys, cannot recover these keys. And this is the reason we need to understand these new technologies, how we can equip the network with this new technologies of post-quantum cryptography. In this course, we also talk about the IoT security, because nowadays we are using IoT devices a lot. And as an security analyst or as an attacker, I think IoT devices, the hackers, they love these IoT devices. And the reason behind that is they are small, sorry, they are very small, and we cannot implement a very, very heavy encryption algorithms or heavy authentication in these IoT devices right? Because of the resource constraint. So it's easy for attacker to hack them instead of hacking a computer or instead of hacking a bank. It's very easy. And if you see, we are surrounded by IoT devices nowadays. And therefore, the second course of this work package consists of the IoT security, the first part. And we talk about the security breaches targeting the IoT. And in the second part, we talk about the quantum key distribution. We talk about the post-quantum cryptography. And in this course, you will learn how we can use new updated encryption or authentication algorithms that are actually safe against the quantum computers. You will also learn one technology that is called the quantum key distribution, and quantum key distribution actually is something that is very useful to exchange the keys between the Alice and Bob, and it uses a kind of photon. And there is a property of photon that if an attacker try to measure the photon, it will actually collapse, and Alice and Bob will quickly know that somebody is trying to hack the network. And therefore, we say that quantum key distribution is very safe to secure the keys. And recently, we have also developed a quantum channel between Odense and Copenhagen. And this link is still active, and we are using these links for the communication. So probably there will be enough job market for these technologies in the future, and therefore I believe this area is very much useful for you guys as well. In the third course, we will cover the blockchain security and privacy, where you will learn about the distributed ledger. You will learn about the blockchain and cryptocurrencies. You will also see a lot of different applications of blockchain, for example, the cryptocurrencies. And we also talk about the privacy enhancing technologies such as zero knowledge proof, multi-party computation, and homomorphic encryption. That means how we secure the data in terms of a privacy so that no one else can have access of it. In generally, all of you know, maybe you know that Aalborg University is a problem-based learning. We follow this structure. So that means in the first part of the lectures, we try to give the theoretical knowledge, and then we try to find out some real-world problems, and we do some kind of practical things to solve that problem. So most of the classes is just like we give you some theoretical knowledge, and next 1 hour or 2 hour, you will work together on some problems, and you will apply the knowledge you have gained in the theoretical part of the course. We also have a lot of mini projects. Of course, it depends on the teachers of different courses, where you learn a lot. And if I talk about the structure of this course, the first course, the applied cryptography, is we don't have any project that is mandatory for your exam. This is just pass and fail exam, where you learn about applied cryptography. But that course is very much useful for the next 2 courses when we talk about the post-quantum cryptography, IoT security, and when we talk about this blockchain and privacy. It is very much important that you have fundamental knowledge of the cryptography course, first course. And in the third course, blockchain and privacy, you are supposed to develop a kind of a project, and that project can be maybe some decentralized applications or some blockchain applications that you will submit, and we will evaluate you on the basis of project and the oral exam. You can see the dates for these exams on the web page, but mostly it's Wednesdays. And yeah, I think that's it from my side.
Thank you very much. Ashutosh, there's no questions in the chat, so I'll just say thank you and tell you all that you're also welcome to contact Ashutosh if you have any questions, and also his data you'll find on our webpage. So thank you everybody from today, and I hope you have a nice afternoon. Thank you very much.